Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2023, Paper 1, FoundationTier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. Here is a list of numbers. I've got 14, 9, 20, 29, 3, 45 and 33. A says which number in the list is a multiple of 4. So a multiple of 4 is going to be a number in the 4 times table. So it's that one there, isn't it? That's the multiple of 4. It's going to be 20. And B says which number in the list is a square number. Well, the square numbers, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So it's going to be that one there, isn't it? That's the square. So 9 is the square. Part C says which two numbers in the list have a total of 43. So which can I make 43 out of? Obviously not 45. 33 would need 10, which I don't have. 3 would need 40, which I don't have. 20 would need 23 that I don't have. 29 would need 14, which I do have. So it's going to be 14 and 29 then, isn't it? 14 and 29, that makes 43. And then part D says work out the largest number in the list divided by the smallest number in the list. Okay, so what's the largest number in the list? That is going to be 45. 45 is the biggest. Divided by the smallest number in the list. The smallest number in the list is 3. So how many times does 3 go into 45? Well, it goes into 45 15 times, isn't it? So 45 divided by 3 is 15. Question 2a, here is a square. Use a ruler to measure a side length of the square. Give your answer in millimeters. So you're just going to get your ruler out and measure along this length here. Now you see mine doesn't actually have any numbers on because this is a virtual ruler. If you had a real ruler and it was a real paper, it does come out to be 56 millimeters on the scale. Can't really show you that here because my ruler doesn't have numbers, but it should be 56 millimeters. Now, if you're using a paper that you got from your school, sometimes my school, when they give them out to students, they reduce them down to A5 booklets. So obviously, if they've done that to your booklet, it isn't going to be 56. So as long as you know how to use a ruler, you're good for your exam, isn't it? Just make sure you know how to use your ruler and can measure things to the nearest millimeter. Part B says, here is a quadrilateral. Use a protractor to measure the smallest angle. Well, the smallest, most narrow angle is going to be this one here, isn't it? That's the one I need to measure. Now, you need to lay your protractor down so that the bottom line of the protractor lines up with one of the lines of your angle. Start from the 0 scale and then read around. Now, I make that 50 degrees. You should probably be able to get like 1 degree either side of that. Okay, so I'm going to go for 50. Part C says a different quadrilateral is shown on the centimetre grid. Look, we've got a nice trapezium drawn here. By counting squares, work out the area of the quadrilateral. Okay. Now, this quadrilateral is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 whole squares. 12 whole squares, and it also has 1, 2, 3, 4, 5, 6 half squares, doesn't it? 6 half squares. Okay, so those 6 half squares are actually going to work out to be 3 whole squares altogether, isn't it? Because you can push 2 together to make a whole square. So my 6 half square give me 3 whole squares plus the 12 whole squares. That's going to give me 15 altogether, isn't it? So the area of this quadrilateral is going to be 15 centimeters squared. And part D says one side of a rectangle is drawn on the centimeter grid. Complete the rectangle so it has a perimeter of 20 centimeters. Okay, so the perimeter is going to be the sum of all 4 sides, isn't it? So I've got like 1, 2, 3, 4 sides, adding up to 20. Now the bottom side that's already drawn from here to here, look, can you see that's like 1, 2, 3, 4, 5, 6, 7 squares in width, isn't it? So if that's 7, that's going to be 7. 7 and 7 is 14. So the other 6 is going to have to come from the other 2 sides. They're going to have to be 3 and 3 then, aren't they? Okay, so we need to draw a rectangle which is 7 by 3. So I'm going to have a line here. Just drawing it this way because that's the way the ruler happens to be. So we have a ruled line from there to there, 7 squares wide. And then in this direction, just going to join those up. 3 and 3. 3. 3. And then 7 plus 3 plus 7 plus 3. That's going to be 20, isn't it? Okay, so there's my rectangle. Question 3a. Work out -4 times -3. Well, 4 times 3... that gives me 12, doesn't it? And negative times negative, 2 signs are the same. It's going to be a positive solution. It's going to be plus 12. Okay. For B, 6 times 5 is 30. So multiplying the 2 numbers together to give me 30. But this time I've got 1 negative sign. So 1 plus 1 minus, that's going to give me a negative answer overall. So it's going to be minus 30. Okay, now -8 squared, that's actually the same thing as -8 times by -8, isn't it? Okay, and a negative times negative is positive, and the 8 times 8 is 64. So I'm going to get positive 64 here. Okay, and then finally 10 cubed. 10 cubed is 10 times 10 times 10, which is 1,000, isn't it? So 1 and 3 zeros basically. Whatever that number there is, that's the number of zeros I'm going to have on the end. 1,000. Question 4. Write 18 out of 30 as a fraction in its simplest form. Well, 18 out of 30 is a fraction, first off. It's going to be 18 out of 30, like that, isn't it? 18 on the top is numerator, 30 is denominator. And then what we're going to do is we're going to look for common factors. Now, what numbers go into 18 and also go into 30? Well, I know that 18 is in the 3 times table and so is 30, but there's actually a bigger number. It's always worth just holding back, see if you can find a bigger one. Otherwise, you're going to have to do more jumps to get to the simplest form. Both of these numbers are actually divisible by 6. So 6 goes into 18, 6 goes into 30. So 18 divided by 6 is 3, and 30 divided by 6 is 5. So this cancels down to 3/5. Question 5. At a shop, the normal price of 1 pen is 24 pence. The normal price for 1 calculator is £7. The shop has these special offers. Pens, half the normal price. Calculators, £1.50 less than the normal price. Work out the total price of 5 pens and 1 calculator using the special offers. Okay. So, what's the price of 1 pen? 1 pen is normally 24p, but at the moment it's half price. So cost of pen equals, it's going to be 24 pence. I'm going to put it in pounds and pence because otherwise I'm going to have mixed units. So dividing that by 2, that's going to give me 12p then, isn't it? Or 0.12. So then if I want 5 pence, going to have to multiply that by 5, so it's going to be 5 times 0.12. Now I know 5 12s are 60, so I'm going to have 0.6 there, aren't I? Because 5 12s are 60, and I've got 2 digits appearing after the decimal place in my question, So I've got 2 a period after decimal place in my answer. Okay, so that's 60p for 5 pence. And then I need to then add on the cost of 1 calculator. What's the offer on a calculator? £1.50 less than the normal price. So what is the cost of a calculator? That's going to be the £7 it normally is, minus the £1.50 that is on offer. So what's 7 minus £1.50? Well, that's going to be £5.50, isn't it? £5.50. So I got £5.50 for my calculator and 60p for the 5 pence. So then adding those together, so 0 and 0 make 0, 6 and 5 make 1, carry 1. So that's, what's that, £6.10? That's my answer then, isn't it? £6.10. Question 6a, write 3 2/5 as an improper fraction. So converting a mixed number to an improper fraction, so you've got 3 whole ones, and if each one of those whole ones is divided into 5 pieces, then 3 times 5 is going to give you 15 pieces in the 3 whole ones, plus the 2/5 you've got there. That's going to be 15 plus 2, which is 17. So I'm going to have 17 pieces, 17 fifths. Okay, and then write 0.19 as a fraction. Okay, well, when you've got decimal numbers, the first digit is tenths, the second digit is hundredths. So I can convert this into a fraction just by putting the numbers over 100. So it's like 19 over 100. Now, does that cancel down? Well, it doesn't ask me to, and I don't think it does, because 19 is prime. So it only divides by 19 and 1, and 100 doesn't divide by 19. So that's just going to be the answer. It's going to be 19 over 100. Question 7. Misha recorded the main type of weather each day for 55 days. The pictogram shows the results for rain, snow, and cloud. And we've got a key here. It says one of those little window things is worth 4 days. And then we've got rain, snow, cloud is complete, but we haven't got anything down yet for sun and fog. Now it says at the bottom, sun was recorded on 1 more day than fog. Complete the pictogram for the 55 days. Okay, so I think what I'm going to do first is I'm just going to work out what each one of these amounts represent. So if I've got 4 big windows for rain, and I know that each one is worth 4, then 4 times 4, that one must be worth 16 then altogether. So it must have rained on 16 out of the 55 days. Snow, I've got 4 and half of a window. So if a whole window represents 4, then half a window is going to be 2, isn't it? So 4 and 2, that adds up to 10. For cloud, I've got 4 and 2. 4 4s are 16 plus 2 is 18. So sun is recorded on 1 more day than fog. So what's 1 more than fog? Well, fog, well, I don't know what fog is. Okay, so that's a slight problem. But I do know that so far I've got 16 plus 10 plus 18, and that adds up to, what's that? 16 and 18 is 28, 34, plus the 10 is 44. So far I've accounted for 44 out of the 55 days. So how many days are left? 55 minus 44 is 11 days left, isn't it? Okay, now I need to share those 11 days between the sun and the fog, and if there was 1 more day of sun than there was of fog, then I'm going to have to, I think it's going to be 6 and 5 then, isn't it? It's going to have to be 6 and 5, because 6 is 1 more than 5, and 5 and 6 adds up to 11. Okay, so now I know how many I need to draw. I just need to go and draw some of those little boxes then, don't I? Okay, so I'm going to have to do what represents 6. So I need 1 big window, because that represents 4. Okay, and then half a window. Okay, like that. So that's going to be 6. And then 5, I'm going to get 1 big window. That's 4. And then I need 1. So that's going to be like a quarter of one of those windows. Just going to be 1 little square like that, isn't it? That's going to be 5. And that's it. That's my job done. Question 8. I've got a formula and it says t is equal to 5p minus w. I'm not quite sure what formula that's about, but all I need to do is work out the value of t when p is 4 and w is equal to 2. So this is a substitution question. What I need to do is I need to take the value of p, which is 4, and replace it here where the p is, and I need to take the value of w, which is 2, and write it there, and then work out what the value of t is. Okay? So subbing those in, t is equal to 5 lots of p, we know that p is 4, minus w, when we know that w is 2. Now I like to substitute into brackets like that, just draws attention to where I'm putting the numbers in, and it kind of helps if you've got negative ones actually. We'll look at that in a minute, I think. So then working that out, 5 times 4, that's 20, minus 2, that's not 54, it's 5 times 4, isn't it? 5 times 4 is 20. 20 minus 2 is 18. So that's my answer then. T is equal to 18. Okay. Now on the next one, it says work out the value of P when T is minus 40 and W is 10. Okay. Now at the moment, I've got a formula in terms of T. It's T is equal to. So it's a really good formula if I want to work out T. It's not such a great formula if I want to work out P. So the first thing I'm going to do is rearrange it and make P the subject. Okay, so taking my formula, T is equal to 5P minus W, I'm going to rearrange it so it says P is equal to something instead. Okay, now I can do that first by trying to get P by itself. I'm going to add W to both sides. Okay, this one will cancel, leaving with 5P on the right. So 5P is going to be T plus W then, isn't it? Okay, and then the next thing I'm going to do is I'm going to divide both sides by 5. So I'm going to divide by 5, divide by 5. That will cancel there, look, leaving me P by itself. So P will be equal to T plus W over 5, like that. Okay, so that's my formula for P in terms of T and W. Let me just swing that around and write P at the front. So P is equal to T plus W over 5. Okay? Right, so now I've got the formula in terms of P, I can then go ahead and sub these numbers in then, can't I? So I know then that T is minus 40, so I'm going to put that there where the T is. And I know that W is 10, so I'm going to write that there where the W is. Okay? So subbing that in, T is equal to minus 40 plus W, which is 10, all over 5. Okay, so minus 40 plus 10, that's minus 30, and minus 30 divided by 5, that's going to be minus 6 then, isn't it, as an answer? Okay, so that's my final answer. P is equal to minus 6. Question 9, match each box on the left to the box on the right with the same value in. One has been done for you. Okay, so I've got strictly fractions on the left. I've got a whole mix of things on the right here. So probably it's better to start with the things on the right and make them into fractions then, seeing I'm going all one way. So what is 0.05 as a fraction? 0.05, that's going to be, it's a bit like the one we did earlier, didn't it? So it's going to be 5 over 100 as a fraction. Now both of those are divisible by 5. So that's the same thing as 1/20th. Have I got a 1/20th to match it up with? Nope, that's not going anywhere then. 20%, what's 20%? 20% means 20 out of 100, doesn't it? Because a percentage is just a fraction over 100. So cancelling those down, that's 2 over 10. And 2 and 10 are both divisible by 2, which is the same thing as 1 over 5. So that one's 1/5. I do have a 1/5 one to join that one up to. So let's join that one up. 1/5 goes with 20%. 2/6. Well, dividing top and bottom by 2. It's going to give me 1/3 then, isn't it? So that's the same thing as 1/3. Have I got one of those? No, that isn't going anywhere. 0.25. 0.25. That's the same thing as 25 over 100. Both of those numbers are divisible by 25. Let's divide by 25. That's going to give me 1 over 4 then, isn't it? That's a quarter. I do have one of those, so I can join that one up. So joining a quarter up with 0.25. And then finally 10 over 20. Well, 10 over 20. You can see I can just divide each one of those by 10. It's going to give me a half, isn't it? So I can join the 10 over 20 with the half. Okay, so I've got a pair for everything. So that's it, we're done then, aren't we? Question 10, we're given that A is 8 times 3 plus 2, and B is 21 minus 15 minus 4. And we need to work out the answer to A times the answer to B. Okay, so let's work out what A and B are first. So what's A? 8 times 3 plus 2. Now we've got to use the order of operations here, sometimes summarized by the letters BIDMAS, brackets, indices, division, multiplication, addition, subtraction. So BIDMAS is a way of remembering the order of operations. So what order do we have to do these things in? Well, I've got a multiplication and I've got an addition, and you can see that multiplication comes first in the list, so we're going to have to do the multiplying first. So what's 8 times 3? 8 times 3 is 24, and 24 plus 2, that is equal to 26. Okay, so A is 26. What about B? B, that's 21 minus 15 minus 4. Now this time we've got brackets first. We've got to do brackets first. So that's the bit we're going to have to do first here. So 15 minus 4, that's 11, isn't it? So 21 minus 11, and then we can do the subtraction last. Then got subtraction to do. So 21 minus 11, that's equal to 10. Okay, so I know that A is 26 and I know B is 10. So what is the answer to A times the answer to B? That's going to be 26 times 10. That's going to be 260 then, isn't it? So that's my final answer, 260. Question 11, convert 7 gallons to litres. Use 1 gallon is 4.5 litres. I'm going to do this as a ratio. So if I know that gallons to litres is in the ratio of 1 to 4.5, and I want the cost or the number of litres in 7 gallons, then to go from 1 to 7, I need to multiply by a factor of 7, doesn't it? So I need to then multiply 4.5 times 7. So 7 lots of 4.5. 4.5 times 7, what's that? 5 sevens are 35. So 5 carry 3. And 4 sevens are 28, plus the 3 is 31. So my digits are 315. Now in my question I had 1 digit appearing after the decimal point. So I'm going to have 1 digit appearing after the decimal point in my answer. So that's going to be 31.5. Okay, so 7 goes with 31.5. Okay, and that's my answer then. It's going to be 31.5 litres. Question 12. Given that October is £120 and November is £240, write down the percentage increase from October to November. Okay. Now I normally do my percentages with a little triangle. FOM. Stick your thumb on it. Just find this quite a handy way of remembering all the different types of percentage questions. So write down the percentage increase from October to November. So it started off being October, which is 120. So my original value is 120. Okay, and then later on it became November. So to November, look, so that's my final amount. So you just need to decide between what's the original and what's the final. And often you can use, you know, past, present, future to help you with that. So we know the final, we know the original. What we want is the percentage increase, which we're going to get from working out the multiplier. So it's the multiplier we don't know. So covering up the multiplier on my triangle, or put your thumb on it to cover up the M. That tells me then that multiplier is equal to the final divided by the original. Okay, so subbing in the numbers, 240 divided by 120. What's that then? That's 240 divided by 120. Well, 120 fits into 240 2 times, so that's going to be equal to 2. Okay, now that's a decimal number. Well, I'm calling it a decimal number, it's actually a whole number, but it's like a decimal number, which has a percentage. I'd have to times that by 100, wouldn't I, to work that out as a percentage. That's 200%. Okay. Now remember, this is a percentage increase that we're looking for, and percentages always start off at 100%. So if it started off at 100% and is now 200%, then the increase is going to be the 200% is now minus the 100% it was to start with, and that is 100%. And so that is my answer. It's increased by 100%. Okay? Question 13. Students choose juice with their school meal in the ratio of orange to apple to lime in the ratio of 5 to 2 to 3. And we've got a bar chart here with number of students and type of juice. Orange and apple have been drawn, but there's nothing for lime currently. And we need to complete the bar chart. Okay. So you'll see that my bar chart for orange is already complete at height 20. And my apple is already complete at height 8. Okay. So the original ratio is orange to apple to lime in the ratio of 5 to 2 to 3. But on the bar chart, I've got oranges at 20 and apple at 8. But I don't have the lime one. That's the one I need then, isn't it, to kind of finish my bar chart off. So from the basic ratio, how many times do I have to multiply that up to get the actual number of students who had that drink? Well, you can see that 20 is 4 times bigger than 5, as is 8 and 2. 2 times 4 is also 8. So if I times 3 by 4 as well, I'm going to get 12. So that's the height that I need to draw my bar for lime. Okay? So when you're drawing your bar chart, make sure that your width is the same. You leave a gap the same between the other bars. So you can see each one of these have got like a space, but 1 square between them. So I'm going to leave 1 square before I start drawing my bar. Okay? So it needs to be a height of 12. And then it also needs to be the same width as the other two. So it needs to be 1 square wide. Okay? Just try and copy the pattern that you've been given for the other bars. Make yours look as much the same as it as you can. Okay, so it should all match. So finishing off my bar there. Okay, might just shade it in quickly because the other 2 bars are shaded. Again, I just wanted to make it match. Okay, question 14. Here's some data about people visiting a gym one week. I've got members and guests and the percentage of all visitors, mean number of hours visiting, and range of number of hours visiting. Compare the data for members with the data for the guests. Make 3 comparisons. So as we got 3 comparisons to make and 3 types of data to compare, it makes sense to do one of each. I'm going to do one comparison on the percentage of visitors. I'll do one comparison on the number of hours being visiting, and I'm going to do one comparison on the range. Okay, let's have a look at the first one first. Percentage of all visitors. So members is 64% and guests was 36%. So you can see that more members are visiting the gym than guests. Okay, so that's my first comparison from then. More members, I'm going to put in brackets 64%, are visiting the gym than guests, which was at 36%. Okay, so there's my first comparison. I like to put the numbers in because it just kind of backs up your argument. Okay, so I've used the yellow stuff. Let's move on to the green one. The mean number of hours visiting, that's 4 versus 2.5. So my second comparison is that members on average attend for more hours than guests. So on average, members attended longer, and that's 4 hours, than guests who attended 2.5 hours. Okay, so that's my second comparison. Finally, range of number of hours visiting. So members was 6 and guests was 8. Okay, so the range is a measure of spread, isn't it? How different the groups are. So I can say there was more variation in the amount of times that guests came, or the other way of saying it is there was less variation for members. I think I'm gonna say more for guests. So there was more variation in the number of hours visited. For guests, range equals 8 than for members. Range was equal to 6. Okay, there's my 3 comparisons. Question 15. A large rectangle has a rectangular hole cut out. Work out the percentage of the large rectangle that is shaded. Okay, so basically we want to have a percentage of the shaded area versus the total area of the rectangle. Okay, so area, what I'm going to do is I'm going to work out the area of the 2 rectangles first. Now, area of a rectangle is given by length times width. Okay, so I'm going to call the big one area of the large one and the small one area of the small one. Okay, so the area of the large rectangle is going to be the length of the large rectangle, which is 4, times the width of the large rectangle, which is 5, and that's going to give me an area of 20. And then the area of my small rectangle is going to be a length of 2 and a width of 3, give me an area of 6. Okay, I'm not going to bother with units just yet because I'm not finished. Work out the percentage of the large rectangle that is shaded. So then the shaded area is going to be the area of the large rectangle minus the small rectangular hole, isn't it? So that's going to be 20 minus 6, which is 14. Okay, so what I then need to do is to do the area of the shaded area, which is 14, as a percentage of the area of the large rectangle, which is 20. Okay, so that's what we're going to do. So the percentage shaded is going to be the 14, which is the area of the shaded part, divided by 20, which is the area of the large rectangle. And what we then need to do is rewrite that as a fraction over 100 if we want it as a percentage. Well, 20 goes into 105 times, so multiplying top and bottom by 5, that's going to give me 14 5s is 70, isn't it? So it's going to be 70 over 100, and 70 over 100 as a percentage is just 70%, like that, 70%. Question 16. Liz travels 18 miles in 20 minutes. Work out her average speed in miles per hour. Okay, so I use another triangle for this. I use the DST triangle, distance, speed, time. To remember which way around these go, I just remember they're in alphabetical order. So distance, speed times DST is the order in the alphabet. Okay, so that's the triangle I'm going to be using. So what's D, what's S, what's T in this triangle? They always give you 2 and they'll give you 1 that you need to find. Okay, so first up I've got 18 miles. That sounds like a distance to me, and that goes there. So the distance is 18 miles. And then I've got this one, which is time, isn't it? 20 minutes. Now, just need to take care because we want the answer in miles per hour. Work out the average speed in miles per hour. So we want the speed, but we want it in miles per hour. So if we're going to work out miles per hour, then the units we use are going to have to match. Now, I'm fine at the moment for miles. That bit's fine, but I need to have my time in hours, and at the moment it's in minutes. Okay, so I need to convert my 20 minutes into hours. Now, 20 minutes, if you think about it, is 26, so that's 1/3 of an hour. So I'm going to write it down as 1/3 of an hour. Okay, and so when I'm working out the speed, I'm going to cover up the speed, and I know then that distance divided by time is speed. So speed equals distance divided by time. The distance is 18 and the time is 1/3. Okay, so we've got fraction division here, haven't we? When you divide them by a fraction, what do? Keep, change, flip, don't you? Keep the first one the same, 18, change the divide into a times, and then flip the fraction over. So it's actually 18 times 3 once. Okay, 18 threes, 18, 36, 46, 54, 54. So it's going to be 54 miles per hour. Okay. Now the key to getting this question right is making sure all your units match up, and that was a really important step there, converting it into hours. Don't get that bit right, the rest of the problem kind of falls apart really. Yeah, so you need to get your units matching from the outset. ABC, BD and BE are straight lines. Angle EBD is equal to 5 lots of angle ABE. Angle DBC is 3 lots of angle ABE. Work out the size of angle EBD. Okay. So I'm just going to go through this line by line and kind of piece together what it means. So I've got ABC, that's this line here. That tells me that, you know, that's like 180 degrees from there. It's a straight line. Okay, that's a useful fact because it means that all those other angles are going to add up to 180 then, doesn't it? Okay, so I've got ABC, so BD and BE. These are all straight lines, aren't they? Okay, good to know. Angle EBD, where's angle EBD? EBD, this angle here then. This angle here is 5 times angle ABE. Where's angle ABE? ABE. All right, now I don't know what this angle is down here, but I know that this other one is 5 times bigger. Okay, so but if I give this a value, let's say I call this one X, then this one over here is going to be 5 times as big. It's going to be 5X. Okay, and then I've got angle DBC, DBC. This angle here is 3 times as big as ABE. Okay, so this one is going to be 3 lots of X. Okay, hopefully that makes sense. So then I've got 3 angles sitting on a straight line, and so I know the sum of them, don't I? I know they're going to add up to 180 degrees. So my X and 5X and 3X add together to give me 180 degrees. So 5X, 3X and X, that adds up to 9X, doesn't it? 9X. So I've got 9X is 180. So then dividing both sides by 9, it's going to leave me with X is equal to 20. Okay. Now it didn't ask me about X. It was something I introduced. What it's asking me for is angle EBD. EBD, remember, was this one here. Okay, which is 5 lots of X. Okay, so if I know that X is 20, then angle EBD is 5X, which is 5 times 20. It's going to be 100 degrees then, isn't it? Okay. 2 prime numbers are multiplied together. The answer is an even number between 50 and 60. Complete the calculation. Okay. Well, if it's an even number, then I know that one of them straight away is going to have to be the only even prime number that there is. 2, because otherwise all the other primes are odd, aren't they? And odd times odd would be odd and not even. Okay, so it's going to have to be a 2. And then I suppose the other one needs to be a prime somewhere between 25 and 30, doesn't it? Because when I multiply it by 2, I'm aiming for between 50 and 60. So half of 50 is 25, half of 60 is 30. So our prime needs to be somewhere in between. So what are the prime numbers between 27 and 30? Well, it's not a whole lot. It has to be an odd number, doesn't it? And it can't be 27 because 27 is divided by 3 and 9. It's going to have to be 29. So 29 is the prime number. 2 times 29, that is 58, which is an even number between 50 and 60. Okay, I think we're done. Andrew and Bruce share some money in the ratio of 5 to 6. Bruce gets £96. Andrew gives a quarter of his share to Carl. Bruce gives 2/3 of his share to Carl. How much money does Carl receive? So I'm going to start at the top with this ratio. I know that Andrew and Bruce share the money in the ratio of 5 to 6. And I know that Bruce gets £96. Okay, so if I've got a ratio between Andrew and Bruce in the ratio of 5 to 6, and I know that Bruce's share is 96, then that is just a multiple of the base ratio, because 6 goes into 96. What's that? 16 times. Okay, so 16 lots of 6 is 96. So on the other side, 16 lots of 5, that's 80, isn't it? So that's going to be 80 to 96. So that's the amount that that Andrew and Bruce get. So Andrew gives a quarter of his share to Carl. So Carl's share is going to be a quarter of Andrew's share, which is 80, plus 2/3 of Bruce's share, which we know is 96, was given in the question. Okay, so what's that then? 4s into 80 go 20 times, so that's just 20, isn't it? And 3s into 96, that goes 32 times, and then 2 lots of 32, that is 64. Okay, so he gets £20 from Andrew and £64 from Bruce, given a grand total of £84. So that's my answer, £84. Question 20. Players score points in a game. The scatter graph shows the time played and the points scored by some players. So you've got points up the side in thousands and time played along the bottom in hours. Circle the strength and type of correlation shown. Okay. Now, handy to get your ruler out here. Now, you can capture all of the points. If you've got like a see-through ruler like me, try and capture all the points under the ruler, and you can kind of see then that mine all go up in a nice neat band running up the middle here. So once I kind of angle my ruler so I've captured all of the values underneath the ruler, then you kind of just pull it down so it's halfway, and then that is where I'm going to draw my line of best fit then through the data points. Okay, so that worked out quite well, didn't it? Okay, so that's what I normally do. So just try and catch them all under your ruler and then drop down a bit and draw your line. Now, that line is sloping up, so that is positive correlation, isn't it? So it's definitely not weak negative, and it's definitely not strong negative. So we know it's positive, so it's going to be one of the first two. But is it weak positive or strong positive? Now, I would say these are all pretty much in a line, aren't they? There's a little bit of variation, but I think that's pretty strong correlation. You know, if it looked more like, I don't know, a bit wider apart like that, I would say was more like weak correlation. But this is all quite neat, not far, every point is not that massively far away from the line, is it? So I'm going to say that this is strong positive correlation. Okay, and then part B says players get 1 extra life for every 2,000 points they score. Jonah plays the game for 15 hours. Use a line of best fit to estimate the number of extra lives he gets. Okay, so once you've got your line of best fit drawn on the graph, you can use it to make estimates of other values for points that you don't have data for. Now it says that Jonah plays the game for 15 hours. So we're going to look up from 15 and across, and then we're going to work out the number of points he gets, or should get, for playing at that amount of time from our line of best fit. Okay, so can you see if I read up from 15, I hit the graph about there, and then I'm going to change direction, and I'm going to draw across to the other axes like that from 15, and I'm going to have to estimate what that value is there at the axes. So it's kind of between those squares. I think it's pretty much in the middle. I actually drew the line a little bit high because my ruler's not that accurate, but I actually think that's pretty much smack bang between 30 and 40. Actually, if I look at where the line is here at this point, it's definitely halfway between those lines. I did draw my line a little bit over the top of where I wanted it to. But the accuracy of my ruler is not so good on this thing. Hopefully yours kind of went across a bit neater. But anyway, I'm going to say that's about 35, and this is in thousands of points. So that means 15 hours goes with 35,000 points. Okay? So what's that then? So how many lives do I get for that? A player gets 1 extra life for every 2,000 points. So how many extra lives are you going to get for 35,000 points? Well, it's going to be 17 lives, then, isn't it? Okay, it's not quite. I can't have half a life. That's not how these games work. You know, when you get a life added to your score, you get 1 extra whole life. So we're not going to write 17.5. We're going to have to round it up or down. And you don't get the life until you exceed the next level, isn't it? So it's going to be rounded down in this case. So it's going to be 17 lives. Okay? 17 extra lives. That's a lot of life. 2a times 3 times 5 squared is 600. work out the value of A. You must show your working. Okay, so so this is 600 written as a product of its prime factors. We know everything apart from the power of 2. But we want to work it back out then. So just multiplying this outlook again. So 5 squared is 25 times 3 is 75. So we've got 2 to the power of A times 75 is equal to 600. So if I suppose if I divide both sides by 75 then they'll cancel, leaving me with 2 to the power of A. And then 75 into 600, is that 8 times? So 2 to the power of A is 8. Well, 8 is 2 cubed, isn't it? So 2 to the power of A is 2 cubed. So A must be equal to 3. Just comparing the indices there. So if the base numbers are the same, 2, 2, I can compare the indices and say that A is equal to 3. Expand and simplify fully. 5 lots of 3x plus 4 minus 2 lots of x minus 1. So this is not double brackets, it's repeated single brackets. So we're just going to be doing multiplying out of single brackets twice and then collecting like terms. Okay, so the first single bracket is 5 lots of 3x plus 4. So multiplying both things inside the bracket with the 5, I'm going to get 5 lots of 3x is 15x and 5 lots of 4 is 20. Now just take care with the second bracket because I've got a minus 2 at the front. So we're going to multiply everything inside the bracket with negative 2. So negative 2 lots of x, that's just minus 2x. And then when we've got negative 2 times negative 1, negative times negative is actually going to give me a positive value, isn't it? It's going to give me plus 2. Okay, so then I've got two types of terms. I've got terms in x and I've got numbers. So adding the terms in x together, 15x minus 2x is 13x, and 20 plus 2 is 22. And that's going to be my final answer then, 13x plus 22. Erica tries to sketch the graph y equals 1 over x, where x is not equal to 0. Make 2 different criticisms of her sketch. Okay, well, now, you need to know the basic shapes of all the various curves that might come up in the paper. This one is called a reciprocal curve, and the basic shape looks like this. Okay, so if I just quickly draw it. So knowing what the basic shape is, I can clearly see what's wrong with this one. First off, she's got this part up here. It's in the second quadrant, isn't it? Whereas in the actual graph, it should appear down here. Okay, so what she's drawn, graphs that look like that with one in the positive quadrant is going to be like 1 over x to a power like x squared or x to the power 4 to an even power. Then you get one on the top of the line like that. But when it's just 1 over x, it's going to be in the third quadrant and not the second. Okay, so I'm going to write that down. So negative half of curve should be below the x-axis in third quadrant. That's kind of two ways of saying the same thing. I'm not quite sure why I wrote both, but anyway, just being very clear. So the negative half of curve should be below the x-axis in the third quadrant. So the third quadrant, first, second, third, fourth. Okay, so the third quadrant is that kind of bottom left corner of the graph. So that's one of my criticisms. The next bit here is this bit up here. It's actually touching the curve, whereas you can see on mine, it kind of gets close to the axes, but never crosses or touches. Okay, so I'm going to write that down. So graph touches the y-axis, but graph is undefined at this point. Okay, so the graph touches the y-axis, but the graph is undefined at this point. Okay, so you know, at the point where x is 0, this graph is essentially infinite, isn't it? It's going to be, you know, flying off to infinity. So yeah, we say it's undefined at that point. We don't really like dividing through by 0. It's like why this bit here was excluded in the first place, so avoiding the fact that we don't want to divide by 0 and get an infinite solution. Sunita is X years old. Beth is 1 year younger than Sunita. Joel is double Sunita's age. The mean of their ages is 5. How old is Joel? Okay. So we know that Sunita is X years old, and we know that Beth is 1 year younger than Sunita. So if Sunita is X, 1 year less would be X minus 1. And then Joel's age is going to be twice Sunita's age. So 2 lots of X is 2X. Okay. So to work out a mean, we add all the numbers up, don't we? So if we add all those numbers up, so X plus X minus 1 plus 2X, the sum of those is going to be 2X, X, and X, which is 4X minus 1 then, isn't it? Okay, so that's the sum. And then to find the mean, we take the mean score is the total divided by the 3 ages then, isn't it? Or the 3 of them that there were. So that's going to be 4x minus 1 over 3. Now, if the mean age is 5, what does that make the value of x? Well, I've got 4x minus 1 over 3 is equal to 5. So multiplying through by 3, so times 3 times 3, that's going to cancel, leaving me with 4x minus 1 on the left. 4x minus 1 is equal to 15. Okay, adding 1 to both sides. That's going to give me 4x is equal to 16, and then dividing both sides through by 4. That's going to leave me with x is equal to 4 then. So that's my solution. X is 4. Is it? No, it's not. How old is Joel? Read the question. Joel is double Sunita's age. So remember, Joel was 2x. So that's going to be 2 lots of 4 then. That's 8. So the answer is 8. You almost caught me out there, question. Question 25. Work out 2 1/3 divided by 4/5. Give your answer as a mixed number. Okay. So I've got to do some fraction division here. Now my first number is a mixed number already, isn't it? That's not so handy for doing division. What I'm going to do first is convert it into an improper fraction. So again, if I've got 2 whole ones and each whole one is divided into 3 pieces, then 2 times 3 is 6. There's 6 pieces in those 2 whole ones. Plus I've got another third, so adding on 1 to 6, that makes 7 thirds altogether, doesn't it? So I've got 7 thirds, and I'm dividing it by 4/5. Now again, we just did this a minute ago. We've got some more fraction division. So keep the first one the same. Change the divide into multiply. Flip the second fraction over. Keep, change, flip. KCF sounds a little bit like a popular fast food chains. Other food chains are available. So 7 thirds times 5 quarters. What's that then? So can't cancel anything down. So I'm just going to go ahead and multiply. 7 times 5 is 35. 3 times 4 is 12. Okay, so you can see my answers end up being another top-heavy fraction with the numerator part bigger than the denominator. So to take that and convert it into a mixed number, what I need to do is think, well, how many times does 12 fit into 35? Well, 12, 24, 36. It goes in 2 times is not enough, 3 times is too many, so it goes in 2 whole times. And what's the remainder? 2 12s are 24, so the difference between 24 and 35 is 11, isn't it? So the remainder is 11. So I write the remainder is the numerator, and then 12, my original divisor, is the denominator. So the answer is 2 and 11/12. And that's my final answer. It's a mixed number. It's the right answer. I'm good. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides, and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.